Welcome to Wildcat Science with Mrs. Haugo. This is Chapter 8, Section 4 on formula masses, and this is Part 6. So previously you found the percent composition of each element in lead 2 chloride. Now we're going to figure out how you calculate the percent composition using mass. So please write this down. First thing you do is you add up all the individual masses to get the total mass. Then you calculate the percent of each element using the percent composition equation. So let's do it. So using chromatography, a sample of white powder was found to be 1.05 grams carbon, 0.16 grams hydrogen, and 1.29 grams oxygen. Calculate the percent composition of each element. Okay, so it's time to do this. Calculate the percent composition of each element. So first thing we're going to do is add up all the individual masses. So get out my calculator, and the total mass is equal to 1.05 grams plus 0.16 grams plus 1.29 grams, and that gives me 2.5 grams. Alright, so now I need to figure it out for each element. So I write my equation, percent comp, and we're going to be doing carbon first. Carbon equals element over total times 100. And the percent comp of carbon is 1.05 grams over 2.5 grams times 100. And what do we get? 1.05 divided by 2.5 times 100. So percent composition carbon equals 42%. Okay, so let's do hydrogen. Percent comp hydrogen. On this one I will let you just sub in your numbers. You don't have to write the equation again. So that is 0.16 grams over 2.5 grams times 100. Percent comp hydrogen equals 0.16 divided by 2.5 times 100 equals 6.4%. And then again, percent comp of oxygen is going to be 1.29 grams. 0.29 grams over 2.5 grams times 100, and our percent composition oxygen equals 1.29 divided by 2.5 times 100 equals 51.6%. Alright, we'll write it very nicely for everybody. Percent composition, we had first carbon, which is 42%. I'm going to rewrite this differently. 42. Looks like I'm going to my hundredths, so I will go to the hundredths because it is exactly 42%. And then I had 6.4% hydrogen and 51.6% oxygen. Alright, so now I'm going to double check my numbers. 42 plus 6.4 plus 51.6 equals 100. So that seems reasonable. Put a box around my answer, and I did my percent composition using masses. Okay, great. Now that you can do that, a question is this sample sucrose? C6H12, sorry, sucrose, not glucose. C12H22O11. Well, how in the world are we supposed to know? Give up? No. What do we know? We know the percent composition. We know the chemical formula. Can we find the percent composition of a molecule given the chemical formula? Yes. So if the percent composition of sucrose is the same as this percent composition, they will be the same molecule. So let's do this. So this was the first type. We know our first step is to write the chemical formula. It's already been done for us. That's wonderful. The next step is to find the total mass, the molar mass of the compound. And I will let you shortcut this a little bit, since it's a multi-step problem, and you should be getting the hang of this. So we have 12 moles of carbon, and its molar mass is 12.01. And then we have 22 moles of hydrogen, and its molar mass is 1.01. And we have 11 moles of oxygen, and its molar mass is 16, for a total of, and I always want to tell people what I'm doing when I'm writing out my questions. Molar mass equals 342.34 grams. Okay, good. And then what we need to do as our third step is to find the molar mass of each compound. So sometimes it's easier if you write it out, because then you know the molar masses and you don't have to go back and calculate them. So just an FYI. Alright, so let's start out with carbon. So the percent composition of carbon equals our element over our total times 100% composition carbon. Okay, so if we had written it out, we would already have this number, but now we got to go back. 12 moles of carbon times its molar mass is 144.12 grams carbon over our total, which is 342.34 grams times 100% composition carbon equals times 100, 42.098, so that would round up to 10%. Okay, so this is something we've done before, so I would like you to figure out the percent composition of hydrogen and then of oxygen. Okay, reviewing hydrogen, percent composition of hydrogen is 22.22 over 342.34 times 100, and you should have gotten 6.49%. Now let's look at oxygen. Okay, for oxygen, its molar mass is 176 divided by 342.34 times 100, and you should have gotten 51.4% oxygen. Okay, we'll write this out nicely for people. Our percent composition, starting out with carbon, was 42.10%, and hydrogen was 6.49%. Kind of lining up the decimal just a little bit, but not very nicely. Okay, and then 51.4% oxygen. And let's compare those to our older numbers. Okay, when we compare them, originally we got 42% carbon, and here we got 42.1% carbon, and 6.4% hydrogen, and 6.49% hydrogen, and 51.6% oxygen and 51.4% oxygen here. These are all within 1 or 2 hundredths of each other, so yes, they are close enough. Our compound, our white powder, we're okay. It's sugar, not cocaine, not heroin, not something else that shouldn't be at this scene. The person is innocent. It is just sugar. In this video, we covered several different calculations of percent composition. We're going to start a new topic, and we'll really dive into it in the next video. Okay, so we're going to talk about calculating empirical formulas. And we talked about empirical formulas before. They are the formula in lowest terms. So if it was C6H12, the lowest terms would be C1H2. So just lowest terms formula. Okay, so the first thing you do, please write this down, is if elements are given in percents, pretend you have 100 grams of that substance and turn all the percents into grams. So if they say 45%, then you would say 45 grams. Number 2, if elements are given in mass, you're going to convert each mass into moles. So here's our mass to moles problem that you have to remember how to do. And then the third thing you're going to do is you're going to circle the element with the smallest amount of moles. That is your smallest part of your ratio. So you're going to divide everything by the smallest. So divide all the moles by the element with the smallest amount of moles. So whatever number of moles this was, you divide each element by that. Okay, adjust the ratio so they are whole numbers and in lowest terms. So let's say it was 1.5. Well, then you would multiply everything by 2. And if it was like 1.3, well, that, if you times it by, or let's say it was 0.3. If it was 0.3, then if you times it everything by 3, then you could get a whole number, because 0.33 times 3 is 1. So really, we're only going to get as complicated as maybe timesing it by 2 or 3 to get our whole number ratios. And if needed, again, you may need to multiply all the ratios by 2 to get whole numbers. So if you had 2 and 1.5, you times everything by 2, you would get 4 and 3 are your ratios. Finally, write the empirical formula out. So you write your element and then your numbers that you found, those ratios, as subscripts. Okay, please write this down. Mrs. Haugo found a jar labeled copper oxide in the lab. Is it copper 1 oxide or copper 2 oxide? What we do know is the sample is made of 2.96 grams copper and 0.37 grams oxygen. So please write that down, and we're going to jump into things in our next video. We'll see you then.